Hello everyone, this is a video for lesson 7.1b. We're going to briefly review measures of center and variation, and then we're going to start talking about our new goal, which is to find the variation in a data set according to adding, subtracting, or multiplying. And when you multiply, it could either be a growth or decay. So let's go ahead and get to the review. All right, so I went ahead and I wrote down the answers to part A. Let me show you how I got those using Desmos. So all you need to do is just enter your data. Make sure that when you enter your data, use a capital letter. We're going to hit equals and then open bracket, and then just separate each number using a comma. Okay, so it's really easy to find the mean. Just type in the word mean and then open parentheses, and you have to put A. The reason why you have to put A is that way you can tell Desmos which data set that you're trying to use. So the mean is 20. The median is $19.50. There is no code for mode, and if you forget that, you can kind of see that it doesn't make sense when you try to type it in. So all you have to do is go back over here and look and see what numbers occur more than the others. So it looks like you've got a couple of 12s. Everything else is there one time, so your mode is 12. So part B says, determine which measure of center best represents the data. Well, in this case, it's going to be either the mean or the median. They're already pretty close to each other anyway, so it doesn't matter. Typically, you're going to use the mean as long as your data is normally distributed, which is something we haven't talked about yet. So we will talk about that later on in section 7.3. Part C says find the range of the process for each company. So we have to do company A. I'm going to say range of A, and I'm going to do range of B. Now there is not a range function on Desmos. You can ask Desmos to find the minimum and the maximum, but we don't need to do that. There's only 6 numbers, so we can very easily tell. So I'm going to do the max minus the min. So the range is the difference between the maximum number and the minimum number of each set. So the range is going to wind up being 33 minus 12, which is $21. And the range of B, it looks like that's going to be 24 minus 12, which is $12. Okay, and it says compare your results. So as you can see that the data in set A is definitely more spread out than the data in set B, because 21 is a lot bigger than 12. Okay, part D says find the standard deviation of the process for company A, interpret your results. So let's go ahead and head that back over to Desmos. Now remember earlier in section 7.1, when you type in standard deviation, so it'll be STDEV, you have to put on P for population. So it's going to do the standard deviation, it's going to assume that you're using all of the numbers. And we're going to put A in here. So the difference between no P and P, if you don't use P, it's using something called sample standard deviation. And we're not going to use that until chapter 8. So just make sure that you put a little P there for your standard deviation. So we're going to write down 7.28 for our standard deviation, which is $7.28. Now, interpreting is really important, not as much in Algebra 2, but very important in statistics. So we're going to go ahead and write this down. We're going to say the typical price of a cell phone sold by company A differs from the mean by about $7.28. So if you remember, standard deviation is how spread out the data is. So you always have the mean here in the middle of the data, assuming that it's symmetric. But what you're going to do, the $7.28, you would add 728, add 728, add 728, and then take away, take away, take away, and then it's going to look something like that, unless your data is skewed. But I'm getting into things that are a little bit more complicated, but that's what that is. It is not a measure of center, it is a measure of variation. All right, so here's the new stuff. What we're going to do is discuss how data transformations affect measures of center and measures of variation. So you may want to grab a highlighter or two. Let's talk first about using addition. Now, when I say addition, it doesn't mean that your values are always going to get bigger. They can get smaller, but that just means that you're adding a negative to your data. So just keep that in mind. So measures of center is going to be treated differently than measures of variation. So let's say that you wanted to maybe give a group of employees a raise. If you were going to give them all a raise of $5, how is that going to affect your measures of center? Well, if you're going to add $5 to everybody's income, what that's going to do is that's going to actually add the same amount to your mean. It's going to add the same amount to the median, and it's going to add the same amount to the mode, okay? So measures of center are going to be affected by K. K is that magical number that you're either adding or taking away. All you got to do is just simply add it to any of those measures of center, and then you'll be good. Now, measures of variation, on the other hand, that's different. So how spread out the data is going to wind up being the same. So you can add $5 to everybody's, income, but the range will still be the same. The standard deviation will still be the same. That measure of spread will not change, okay? So if I wanted to draw you a picture, so let's say you've got a mean here of like $15, okay? And your minimum is $2, and let's say that your maximum over here is like $20, something like that, okay? And no, let's make that more than that. Let's do 25. Okay, so if I was going to add $5 to everybody, that's just going to make this 20, that's going to make this 30, and then that's going to make this 7. Your range, the difference between the minimum and the maximum is going to stay the same, except the range is going to stay the same, okay? Except for your measures of center, on the other hand, all of those are going to increase. So your mean is going to increase to 20, and your median is going to increase by 5, and your mode is going to increase by 5 if you have a mode, okay? Now let's talk about transforming using multiplication. Now, something that's not in your notes that you need to write down immediately is that you need to write down that growth. Now, growth is going to make it grow, obviously, and we've done this before, but the K that we're talking about in your notes, the K is going to be 1 plus the rate. So we did this back earlier when we were doing an exponential function. So if it was going to grow by 10%, it would be 1.1. So you have to do the 1 plus whatever percent that you're changing it. And then if you have a decay, on the other hand, it will be equal to 1 minus that rate. So instead of multiplying it times the actual decay of like 20%, you would multiply it times 1 minus 0.2, which would leave you 0.8, okay? You're not really going to have to worry about that so much, but it's mostly going to be growth. So the easy thing about this, though, whatever K winds up being, you're going to equally multiply all of this stuff. So if you wind up growing anything or decaying anything, you're going to multiply every single one of these by whatever that growth or decay is. So if I decided to give everybody a 10% raise, every single one of these measures of center and variation will change by whatever that is. So if I multiply it, so let's say if I give everybody a 10% raise, this is what's going to happen. You're going to do 1 plus 1, 0, and that means K is going to be 1.1. So all of these, the mean, the median, the mode, the range, the standard deviation, those are all going to change because you would multiply all of that by 1.1. And I'm going to show you what that looks like on Desmos in just a second. All right, let's take a second and look at this new example. We've got a manager. They're considering either increasing all of the hourly wages by either $1.25 or they're going to increase by 10%. So immediately what I'm going to do is I'm going to clear all of this stuff out and I'm going to type in these wages. I'm going to name this set A. You guys go ahead and type this in as well. All right, so I've got all 8 in my list, and the first question is, which increase results in a greater mean hourly wage? So the mean is a measure of center. So if I was going to add so much money, the mean is going to change by that much that I'm adding. If I'm going to multiply, though, by 10%, what I'm going to do is I'm going to multiply the mean by 1.1. So what you can do is you can figure out what the mean is right now. So that is $9.65. So I'm going to go over here to my notes. So without a raise, the mean is $9.65. Okay. Now, what I'm going to do is I'm going to add the, what was it, $1.25 here. And then over here, I'm going to increase by 10%. Increase by 10%. Okay, so adding $1.25 simply is just going to add $1.25 to the current mean. So you can just use your calculator and add $1.25 to that. So $9.65 plus $1.25 is going to give us $10.90. So what's really neat is that you can do this inside Desmos as well. So if you wanted to change your mean, you can just add $1.25 to it and it will automatically do it for you. So it's kind of neat. Okay, the increase. Now you got to be really careful. You do have to consider whether or not this is a growth or a decay. If it's increasing, we're going to grow. So that means I'm going to take 1 and I'm going to add 10% to that. So K is 1.1. So if I wanted to change that, I would say 1.1 times the $9.65. That is going to be equal to $10.62. So which one increases the results more? It looks like adding $1.25 is going to answer that question. Next up, which increase results in a greater range? Okay, so the range of A, now you remember you can't use your Desmos to do this, you have to find the maximum minus the minimum. I'm going to go ahead and tell you that the range is $8.25. Now if you look back in your notes, if we are going to add any amount to the range, the measure of variation will stay the same. Okay, so if I add $1.25, there will be no change to this. So the range is going to stay $8.25. But if I increase it by a percentage, it's going to grow the same amount as I did last time, but you're going to actually change it. So anytime you multiply something to a whole data set, you have to multiply all center and measures of variation by that amount, and that's going to increase that to $9.08. So it looks like your range is definitely going to increase, but honestly, as an employee, I'm going to definitely want the $1.25 raise just because I'm going to get more money. All right, the next section is really important. This is a very typical ACT question. You also can see it on your benchmark as well. It says find the missing data value, and it gives you the mean. So instead of you knowing all of the numbers in your data set, one of them's missing. So it's really easy to set this up by hand. What you're going to do is you're going to pretend like you know all of the numbers, but instead the missing number is going to be X or whatever variable you choose to use. Now, if you add all the numbers up, you have to divide by 1, 2, 3, 4, 5 because that's the formula for mean, right? So it is going to be equal to 90 because it tells you it's equal to 90. What you can do is you can go ahead and add all 4 of those numbers really quickly on your calculator. I'm going to go ahead and tell you that that's 372. Just cleaning it up just a little bit. And then what you want to do now is you want to get rid of the 5. So the easiest thing for you to do is just multiply both sides by 5. And then that's going to become 450 on the right-hand side. I'm running out of room. And then just simply solve for x by subtracting 372, which gives you 78. Okay, now that you know how to do that, you can go ahead and attempt this second problem. So pause the video. I want you to try to work out that second problem and unpause the video and let's see if you do it right. Okay, so this is how I set it up. I pretended like I know all of them, but the one I don't know is going to be x. And then I went ahead in my calculator and I added the 4 that I did know. That's going to equal to 102. And then I'm going to go ahead and get rid of the 5. A really common mistake people will do when working these problems out is that they'll forget to divide by 5. They'll divide by 4 because they're like, well, I know 4 of them, but you actually have 5 numbers in your set. Just one is unknown. So be really careful with that. And then all you got to do is finish up the problem, subtract 102, and you get 93, and that's your missing number. All right, so let's practice this transforming data like one more time. So I've got prices for company A, prices for company B. This time we have company B here. It's considering increasing all prices by either $2 or by 10%. So that's going to grow by 10%. Which increase results in a greater mean price? So what I'm going to do is I'm just going to work here and I'm going to figure out the actual mean of company B before I do anything to it. So if you just go to Desmos and type in all the information for company B and you say the mean of B, you wind up with $17.50, okay? So let's get to the question. Which increase will result in a greater mean price? Okay, I don't really have any space here, so I'm going to do this. What happens if I add $2 here? Well, technically, if I take the mean, I'm supposed to literally add $2 to it. So when you're adding, you simply add to the mean, median, and mode, but there's no change on variation, okay? So the mean plus $2 is $17.50 plus 2, which gives me a total of $19.50. All right, now what's going to happen if I add 10%? Okay, equally, this is a growth, remember? So I'm going to actually multiply the mean by 1.1. So the mean is $17.50, and when I multiply that times 1.1, I wind up with $19.25. Okay, so which one of these two results in a higher wage? Adding the $2, okay? All right, last question here on this one. It says, which increase results in a greater range? Okay, so range is a measure of variation. It's going to be affected differently. So the range of the prices in B, that's going to wind up being 24 minus 12, or $12. So this is our original range. So what happens if I add $2? Nothing. Absolutely nothing. So the range does not change. It's going to be the same. And then if I add 10% on the other hand, everything is equally affected. So I'm going to multiply that by 1.1. And that gives me a price of $13.20. So it looks like this one has the bigger range this time. So I think if I had mentioned like pay or anything like that, it's actually, I think, prices for cell phone cases. Yeah. So This one is going to result in a greater price here. Price change is the mean, but over here, the range is more affected when you multiply. So how do you see it? The dot plot shows the ages of members of 3 different adventure clubs. Without performing calculations, which data set has the greatest standard deviation? Now remember, standard deviation is the spread of the data. Which has the least standard deviation? Explain your reasoning. Okay, so if I wanted to look at the spread or the variation of the data, I'm going to look at the minimum and I'm going to look at the maximum. And I'm going to look at the distance between those two right here. So A has a range of about this much. B has a range of this much. Now obviously B has a greater range, and it looks like C has the least amount of range here, okay? So the range here, without even calculating it, because you don't need to calculate it, you can just look at it visually, but the range here is going to be 17 minus 13, which is 4. The range here is 18 minus 12, which is 6, and you can see that it's going to definitely be bigger. And then this one's going to be the smallest one. The range is going to be 2. So clearly the one that has the least standard deviation is C. And then it says which one has the greatest standard deviation. It's going to be B. And it says explain your reasoning. I mean, you can just go ahead and calculate the range, but if they didn't have any numbers down there, you can't do that. You can just say that this one has the largest spread of data, and then C has the least spread of data. And that's how you explain it. And you've got a few practice problems to work on. Just let me know if you have any questions on anything.